Okay, so today we're going to be on page 135, and it's going to be arc length in radians. So our objective for today is to determine the arc length in radians. So we want to recall arc measure. So it's going to be the degree of an arc is equal to the measure of the central angle that intercepts the arc. So for example, if we have circle O with a central angle of, say, 82 degrees. This is point A and point B. So I said that our central angle is 82, so that means that our arc AB is equal to our central angle. So this would be also 82 degrees. So arc length is the length of an arc. So the length of an arc is a portion of the circumference. And the circumference of a circle, if you guys remember, is 2 pi r. So we want to consider this proportion. So it's going to be the central angle over 360 is equal to the arc length over the circumference. So this is also saying that it's going to be part whole equals part over whole. So the central angle for this would be 82 over 360 because the degrees of a circle is 360. And the arc length would be 82 over our circumference, which would be 2 pi r, which r is our radius if we had it defined. So if we want to solve for arc length, we're going to get this equation. So arc length is equal to the central angle over 360 times our circumference. So this is how we write it. Arc length is represented by S is equal to the central angle over 360 times circumference, which is 2 pi r. So now we're going to look at an example. So if we have a circle O, with points A, B, we have a central angle of 60 degrees and a radius of 3. So central angle, or we write angle AOB equals 60 degrees, and our radius is equal to 3. So if you want to determine the arc length, we're going to have S, which is our arc length, is equal to our central angle, 60, over 360, times 2 pi, and our radius, which is 3. So we get S equal to, if we do 2 times 3 gives us 6, and then 60 times 6 is going to give us 360 pi over 360. And our 360s cancel out, and we're left with pi. So our arc length is pi. So now we're going to look at our radian measure. So radian measure of a central angle is the length of the arc, the angle subtends, which is, we said S is arc length, divided by the radius of the circle. So this would mean that our angle is equal to the arc length, which is S, over the radius. So we can write that arc length over the radius. So if we have a picture here, center of 0, so we have our radius of r, and this length here is our arc length, and that's what we label as S. And this would be our angle measure. So we can also write this as arc length is equal to the central angle times our radius. So we want to look at this equation. So now we're going to look at an example, example 2. So we're going to find the length of the arc subtended by the central angle 7 pi over 4 radians with a radius of 20. So if we draw our picture, so we can call our center, we can call this O. And then we have a central angle here that measures 7 pi over 4 radians. And we are given that our radius is 20. So if we use that equation that we created down here, so we want to find the arc length, so we can use S is equal to our central angle times our radius. So arc length equals 7 pi over 4 times our radius, which we said was 20. So when we multiply these together, we're going to leave this in pi, so we have 35 pi. So this would be the arc length.